All right, good morning. Welcome to Activity for Processing 2.12, which will get you ready for Cool Down 2.12, ladies and gentlemen. So, if you could in your notebook, obviously place your title there, make some space for example 1. Here's your equation, which we will be working on. Please do feel free to make as many annotations as you need to. As you're taking notes, just feel free as I take notes, because I'll write some things out. If you feel like, hey, I like what he's writing, but I want to write some more, by all means, write to your heart's content, capture as many ideas as you can, and make sure you don't feel shy because that notebook belongs to you. All right, let's hop into it. So for today's objective, we're being asked to take a polynomial, which I wrote in black here, the polynomial p of x, that's what they call it on the cooldown, is 4x cubed plus 15x squared plus 17x plus 6. This is our polynomial right here. And they're going to ask us to rewrite this polynomial as a product of three linear factors. The three linear factors are here, so allow me to now label here. So this is our polynomial, the one written in black. And they are going to call it p of x. Now, these three here each represent a linear factor. So there are three linear factors. And I'd like to remind you folks that these, you can tell they are linear because they have an invisible exponent of 1. And 1 plus 1 plus 1 will give us this 3 here, this degree 3. So just to remind you folks, once again, these three linear factors, when you multiply them, 1 times 1 times 1. So you add the exponents. So it's like this, x to the 1, x to the 1, x to the 1. If you multiply them, they will give you a cubic, a degree 3. So we're going to take this polynomial, which is degree 3, and break it down into a product of three linear factors. We know the first two, we don't know the third one. That's the whole point of this, is we're going to conduct some polynomial division. That's the name of the title. For this particular lesson, polynomial division. We're going to use that strategy to figure out what this missing value is. All right. Now, what I am about to do, it's going to get a bit messy, but it's all for the sake of organization. I'm going to annotate and label some items so I can kind of keep track of them, and also for my reader here, whoever's watching this, to also see where certain things are coming from, and I can reference them as I move forward by pointing them out or saying, oh, that one. So first thing I want to do here is make sure I put a little cloud around the leading term. This is the leading term. You can always find the leading term of a polynomial by looking at where does the term with the highest exponent, where is that located? So we got an exponent of 3 here, which is the highest exponent out of all of these terms. Next, the second term, I'm going to call number 1. The third term, 17x, I'm going to call number 2. The last term, the constant, I'm going to put a square around. And then I'm going to put a division symbol, a little 1 here, to let my audience know I am going to divide this polynomial, 4x to the third, etc. This stuff right here, this black polynomial, I'm going to divide it by x plus 1 first. Then I'm going to divide again using a second box. So I'm going to call this division 2. So I'm going to divide by x plus 1 first, and I'm going to divide by x plus 2 second. Once I conduct those two divisions, I'm going to divide twice, I will get the result that I want to find. Okay, so I'm going to go ahead and erase the word leading term, but I will keep the rest of the annotations there visible. Next, what we're going to do here is we're going to create a box. And I'm going to draw a few lines to create some squares inside. Now, for our first division, we came to the agreement that x plus 1 here is what I'm going to divide by first. You could have divided by x plus 2 first. That's totally fine. But we're going to go this route. If you want to try this route after you watch this video, by all means, go ahead and try it again by dividing by x plus 2 first and x plus 1 second. Okay, next. So we have set up our box. We have placed the item that we're dividing by, its contents here, x and positive 1. Now I'm going to place this leading term, which I put around in the cloud, right here. 4x to the third power. So once you have this set up, ladies and gentlemen, you're going to be good to go to get started with the process of dividing. Now, I'd also like to remind my crowd, we have seen a similar box being used before for FOIL, where we multiplied two binomials, or a trinomial and a binomial for the extension lesson. However, the same holds true here. These outside values on the edge of this box, and over here as well, you multiply these outside values and the results are found here. For example, if I had, let's say, 5 here, x times 5 is 5x. 5 times 1 is 5. So I'd like to just remind the class that the outside numbers are multiplied to get the inside numbers. There it is. Okay. So now that I just told you folks that, we need to think to ourselves, I can find this number using that logic, right? X times something gives me 4x cubed. Okay, I know we just saw this not too long ago. So it has to be 4x squared. So x times 4x squared gives you 4x to the third power. Okay, now we're going to multiply the outside values 4x squared and positive 1. That gives you 4x squared. All right, now you're going to see right here where I labeled number 1, how this comes into play. So the diagonal values are where like terms are combined. So 4x squared plus something x squared here, we don't know yet what it is, needs to give us 15x squared. Now doing some mental math, I know that 4 plus 11x squared is going to indeed give me 15x squared. However, I invite you to take a look at this down here. What if the numbers were a little more complicated, or maybe even some negatives, right? Well, you can always set up an equation. So 4x squared plus something, I'm going to use a question mark symbol, gives me 15x squared. And then you can actually solve this equation. Now, what I'm going to do here is I'm going to actually kind of make it a little easier for us, a little more approachable. I found this very useful. 4 plus something gives us 15. And we can subtract 4 from both sides. And there it is, 11x squared. So if removing the x squareds away from it helps, that's fine. If it doesn't, you can keep the x squareds there. But I just thought I'd just show the coefficient values, 4 and 11, to show you that that gives me 15. So once again, 4x squared plus 11x squared gives us this 15x squared, which I'll go ahead and write right here. 4x squared plus 11x squared, that gives us 15x squared. And these were these diagonal values. Okay, now that we have that, now let's go ahead and figure out this out. X times something gives me 11x squared. That's 11x. There you are. All right, so x times 11x gives me 11x squared. Cool, let's keep going. 11x now times 1 gives me 11x. Which now brings me to the second item in which I placed number 2 on, right here. So 11x times plus this diagonal value here needs to give me 17x. You can set up your little equation, or you can do mental math. 11 plus something gives me 17. It should be 6. All right, cool. So I'm going to go ahead and write that down here. Remember, it does get messy, but it's all for the sake of making sure that anyone who sees this or whoever's watching this gets a good perspective as to what is being done to get what was annotated earlier. So 11x plus 6x gives us 17x. Okay, I'm done with that. Now I'm going to go ahead, go back to the outsides. I need to figure out x times something gives me 6x. That something is 6. X times 6 is 6x. Cool. 1 times 6 is 6. And if you recall earlier, I did annotate the constant value of a square. And if this last value matches up with that constant right there, you're in good hands. You have done the problem correctly. If you do notice that this last number is different than the constant, you need to go back and find the mistake. So now we have conducted our first division. I'm going to put a little check mark here saying, yep, I got the first division done. Now, out of that first division, I got a new answer, 4x squared plus 11x plus 6. So I'm going to go ahead, draw an arrow, showing myself that after I divide it the first time, this is my answer. 4x squared plus 11x plus 6. Now, did that come on camera? Not really. All right, scoot it over just a bit there. Okay, so 4x squared. Cool. We should be good there. Plus 11x plus 6. That's this value here. I'm just putting it here to show myself that after I divide it the first time, this is the answer I got. Now, that's not our final answer because remember, we need to get a linear factor. This is degree 2, ladies and gentlemen. We are not done yet. We need to get a degree 1 polynomial. So what we're going to do next is we're actually going to annotate this new equation very similar to how we did to the original black polynomial up here. So to do that, I'm going to go ahead and put a little cloud. Let me switch colors there. On the leading term for x squared, and I'm going to label 11x number 1, and I'm going to put a little box around the constant 6. All right, let's create our box now. Okay, now I'm going to put the second linear factor, x plus 2. I'm going to put its contents in these two boxes on the side. Now, just like I did over here, remember how I grabbed the leading coefficient and I placed it in the inside right here on the first square of the inside values? So I'm going to do with this 4x squared now. I'm going to put that right here. 4x squared. All right, the setup has been done. It's conducted. It's good to go. Now we can start doing the process. And if you were a little fuzzy up here, that's totally fine. Let's go ahead and conduct that process and get a little more comfortable with it since this is our first time seeing it. Okay. So now we need to think to ourselves, this outside value and this outside value multiply and give us 4x squared, which means this needs to be 4x. And then just think back to yourself. It's always good to say, okay, it's 4x, but then just calculate it real quick. 4x times x is 4x squared. We're looking good. Now we're going to multiply the outside values, 4x and 2, and that gives you 8x. And now we're going to go ahead, dot our diagonals. And we notice here, 11x is the thing we want to find when we combine like terms here diagonally. So 8x times a mystery value will give us 11x. Now we can do mental math and tell ourselves 8x plus 3x right here. I'll go ahead and write it down. 8x plus 3x gives us 11x. All right, cool. All right, now let's go back to the outside. So x times something gives us 3x. That has to be 3. 2 times 3, that's 6. I put a little square here, and I'm looking good. I'm done. Now, the problem does ask you to write it as a product of linear factors, so I'm going to actually write the answer down here. So the polynomial p of x as a product of 3 linear factors is x plus 1. We already knew that one. X plus 2. We already knew that one. And then the last one, which we found through a lot of work, is 4x plus 3. If you multiply these 3, you will get this original polynomial right here. I promise. All right, let's see where we go. Let's see how we're doing. And for sure, write down as many questions as you need to. And I cannot wait to debrief this with you. See you in a bit.